integral from -5 to -1. I simplify first to x to the third plus 3x squared. So -9x minus, so this is -13x and minus 15 dx plus the integral from -1 to 3, negative x to the third, negative 3x squared, positive 13x. Of course, I always run out of the room. I always have to run out of room, right? And plus 15, of course, dx. And I'm just going to continue here. I'm just going to put a circle and continue here. So you understand that this means that you're jumping over this and continue here. That's how lazy people do it, so they don't have to write it again. So x to the fourth over 4 plus 3x cubed over 3 minus 13x squared over 2 plus, minus 15x from -5 to -1, and then plus negative x to the fourth over 4 minus 3x cubed over 3 and plus 13x squared over 2 and plus 15x, and evaluate from -1 to 3. With your permission, I'm just going to say so on and so forth, because we have to get a number. So you can plug this in, not this, careful, careful. You can plug this in the calculator and get this, so we can do it, so we can finish it up quickly. So, okay. Good. So the function was from -5 to -1. I just don't want to do the arithmetic and waste the time on the arithmetic, that's all. So we have x to the third, and then plus 3x squared, and then minus 13x, and then minus 15, although sometimes just plugging this in takes more time. And then plus from -1 to +3, and we have negative x cubed, and then we have -3x squared, and then plus 13x, and then plus 15, and finally dx. Okay, please give me a number. Anything, I'll write it in. Thank you, 128. Awesome. So 128. That's the area, units squared, the area between, or the area enclosed between these two functions, between this and this, between -5 and +3. We could not use one integral. It's not possible. Above minus below, above minus below. Same thing here, above minus below, and we have to determine these intersects. It appears to be between 1 and 4. Okay, so let's choose one from here in which we are not given the graph, and we're asked to find the area, graphing first, finding the points of intersection, and then determining the area. Do I get to choose? I will choose 21. And 21, we have y equals x squared and y equals the square root of x. A simple example, simple graphs. Okay. Because I know how to graph x squared. We all know how to graph x squared. I'll graph it right away. Here is x squared. I know how to graph the square root of x. Here's the square root of x. And it's very clear what area they are talking about. This is the only area enclosed by these two graphs. All I need to do is identify this point, which I know is 0, 0, and identify this point, which I don't know what it is. I do, but we have to set them equal to each other. At this point, x squared and the square root of x have the same value, the same y value. So then x squared equals the square root of x. This is a radical equation. How do I solve a radical equation which has a square root? Anyone remembers?
Take the square root of...
We square.
Yeah.
To eliminate the square root. So we have x to the fourth equals x. So we move x to the other side and factor out. X to the third minus 1 equals 0. And we know there are only two possibilities. This is the x equals 0. We should have 4 solutions, right? Because the degree is 4. However, from here, we only get 1 real solution and 2 imaginary. So this is x equals 1. So obviously, this is 1. So the area is between 0 and 1. Can anyone tell us how to write this area? How to write the definite integral I meant, and then we will find it together. Can anyone give it a shot? The area. It's okay if you're wrong. Yes? The definite integral?
Yeah.
From?
The just set the integral of 0 to 1.
Excellent.
What's it? X to the fourth minus 1.
From the function above.
Yeah.
The function above.
Square root of x.
Good. Minus the function below.
X squared.
That's it. This was just to determine these points. This has no meaning for the other than that, for the integral. The integral is from 0 to 1 for x equals 0 till that's where the area is. If they intersect here, then the area will be between 0 and this number. But they intersect here, and they go the other, separate ways. So the area enclosed is this. It appears to be only between 0 and 1. So from the function above minus the function below. The function above is the square of the area is the square root of x. The function below the area is x squared. So then we have, remember, we have to change this square root of x into x to 1/2. That's why we studied those at the very beginning, those exponential rules. The integral from 0 to 1 from x to 1/2 minus x squared dx. So then x to 1/2 plus 1, which is 3/2, over 3/2 minus x to the third over 3 from 0 to 1. Luckily, I don't have to plug in 0. I will only plug in 1, and I flip. So this is 2/3 minus 1/3, which is 1/3. Any questions on this? Any questions? Is this okay, everyone?
Yes.
Okay, so this is how we deal, thank you. This is how we deal with areas. So some of them are more involving, like graphing a quadratic function. It's not involving, but finding the intercepts. We have to find the intercepts always. We have to graph. We have to decide which function is above and which function is below. So do you think we need another example, or we are okay?
Can we do one more?
Okay, good. So what about, I don't know, 22, 24? You choose.
22.
22. Okay, let me just copy 22. So y equals 2x minus x squared, and y equals negative x. Okay. So I know how this looks like. Y equals x is this line. Y equals negative x will be this line. So y equals x bisects these two quadrants, and y equals negative x bisects these two quadrants. So I'm just going to graph it right away. This is y equals negative x. Now, for 2x minus x squared, before I graph it, I just want to set these two equal to each other. I have to see where they intersect. So 2x minus x squared equals negative x. This is just for the points of intersection. Points of intersection. Okay, so I will transfer negative x or move everything to the other side. Doesn't matter. 0 equals x squared. If it was negative, it's positive on the other side. It was positive, it's negative on the other side. Factor out x, of course. So I have two solutions. X equals 0 and x equals 3. So the two graphs will have to intersect here when x equals 0, because y is 0, right? When x is 0, y is 0. So the point is 0, comma 0. And when x is 3, y is negative 3. 3, comma negative 3. You can go back here, it says it has to be the same thing. So 3, 1, 2, 3. So the two graphs have to intersect at 0, 0, and 3, negative 3. And now I'm going to graph this one. Remember the leading coefficient. We graphed these functions a long time ago. The negative leading coefficient means that the function looks like this. A negative leading coefficient and a positive leading coefficient. So this is the situation. I know it has to go through these points. I know that the vertex has to be right in the middle, right here at 1.5. So I can draw a rough graph because I know what it is, or I can find the vertex. So the vertex, remember, is negative b over 2a. Negative b over 2 times a. The vertex, sorry, I was looking at this instead of that. So the because I'm getting 1. So I just want to make sure that I delete this right away. So the vertex is at x equals 1. I was looking at the wrong function. So that's where the vertex would be. Okay, so negative b over 2a, which is also negative 2. So this is at 1. So when I plug in 1, negative 1 plus 2, so the vertex will be 1, comma 1. So I have the other graph, 1, comma 1, right here. And here's the graph. And it crosses it too. So this is the area in question. So this was y equals negative x, and this one is y equals 2x minus x squared. Good. So we have the graphs, we have the points of intersection. How do I determine that area, and what do I write? So graphing takes a little while, shading in, finding the area. And now let's calculate the area. So we see the area, but we have to calculate it. Can anyone tell us how to write this? The exact area enclosed. How do I write it?
Integral of
The definite integral, very good, from?
from 0 to 3.
Excellent, yes, awesome. 0 to 3, from?
3x.
The function from above, the
Yeah.
function that limits the area above. What
Yeah.
function is the one that limits the area above?
X squared. 2x minus x squared.
Excellent, 2x minus x squared minus the function that limits, that is at the lower limit of the area. What function is at the lower limit? I have to subtract.
Negative x.
Good. Instead, I'm going to simply write, because it's minus and minus.
Yeah, I was just adding the x to the 2x.
Of course, but I needed everyone to see that. But thank you. Yes,
Yeah.
awesome. I know you're way ahead. 0 to 3 from 3x minus x squared dx. And now we know how to find this. 3x squared over 2 minus x cubed over 3 from 0 to 3. Luckily, I don't have to plug in 0. I only plug in 3. So 9 times 3, 27 halves minus 27 thirds. Okay, so what I normally do in my head, I just factor out 27. I have 1/2 minus 1/3, which is 1/6. 3 minus 2. So I get simplified by 3, 9 halves. Units squared, whatever measurement unit. We're not given anything. It's a fictitious example, right? So this area enclosed and limited above by this function and limited below by this function is 4.5 units squared.